Dominic, first of all, thank you very much for joining me today. I guess let's start off by just asking you what your current role is here at Alpine.
Okay, so at the moment I am actually working with Pierre Gasly as his performance engineer. I've been in Enstone now since 2009, so I was lucky enough to get a graduate position here, actually just as the team was sort of collapsing for the first time, because that was when ING and everybody else pulled out before we had the takeover. But the benefit of that was the team decreased in size a lot, but it also meant I got to do a lot of things that perhaps as a graduate you wouldn't get to do now. So immediately went into vehicle performance group, managed to get involved in the sort of brake dyno work, the tyre dyno work, some sort of event support during the races, doing simulations for pre-event work, all that kind of thing. So I had quite a steep learning curve, but then I think it helped give me the sort of foundation knowledge on all these different ways of modelling and interpreting and correlating data, to then move up through the vehicle performance group, then move to the race engineering department as a support engineer, and then for a couple of years engineered the RST, which we'll discuss in a minute, and then finally onto the race team, working with the race engineers and Pierre throughout the season.
Fantastic. And then back in 2021, you guys ran a special project at Le Mans, where you ran the F1 car. Can you tell us a little bit more about that special occasion? Yeah,
so I'll keep looking at my notes now and again, just to remind myself, but I think where we'll start is, so first of all, we have a group in the company called RST, that's the race support team. This is made up of both junior and senior, but perhaps no one in the middle, engineers, mechanics, logistics, all these types of people who are basically in sort of a training environment, if you like. These people can step into the race team if they're needed, but on day to day, they basically inherited a fleet of cars, and it's up to them to try and run them for whatever needs any part of the company needs. So, as you know, there's still a couple of the 2012 cars up and running at the minute that are primarily used for demonstration purposes mainly. They don't necessarily go quite full chat as they used to, but they can do. And then also under the regulation that's known as TPC, which is testing of previous cars, they inherit a 2-year-old car every year or so, and we primarily use that for young driver training. So Jack Doohan's been doing a lot of the testing at the minute, and it's almost a one-to-one replication of a test event. So to ensure everything is done properly, you basically have to run it like it's the current car, because otherwise you can start to miss things and all this kind of stuff. So the Le Mans project was asked of us by the marketing group, basically, that obviously there was something they wanted to showcase with I think there was an A110 GT car of some sort, their current Le Mans car, and then they wanted Fernando, and what we had at the time was the RS18 to do a lap. So we were tasked with that.
Fantastic. So is it a promotional event? And I guess, as you're mentioning there, those cars are being run to develop both the drivers and the team members.
Yes.
And like you say, you can't run a Formula One car kind of with 50% of the capacity. You've got to run it properly.
No, as you've seen, the 2012 cars are a little bit easier. They're almost turnkey to a degree. The 2012 car, for example, it doesn't have its KERS battery anymore because the V8 was enough to power it. But obviously the complexity of the current cars is to the level that you just have to operate it as if it was running in a race weekend in era. And you have to do the same thing with safety, reliability, performance, all these kind of things. And these cars run under I think it's section 10 of the sporting regulations, which you can just look up and quote. It's all there, where essentially it says the car has to run exactly as it did in era, essentially. So the technical regulations of what would have been 2018 relevant to that car at the time is just what you have to follow verbatim.
Right. So on to the event itself, first question I suppose, was the car being run flat out? Was it being run properly, or some demonstrations, drivers are cruising around?
Yeah, so we did approach it as a sort of a full performance challenge, if you like. Obviously the levers you've got are still whatever the levers you had in 2018. You can't go and design new bits or anything like that. There are occasions with these cars, if things get outlifed or you find an actual reliability concern, all these kind of things, you can update them, but then you have to send all paperwork to the FIA for them to confirm that that's okay to up issue. Additionally, every time we run any of these cars under the TPC regulation, you have to inform the FIA with spec, event, driver, reasoning, all this kind of stuff, for them basically to give the thumbs up, and then they can send delegates if they want to come and watch you run at the same time. Is
the point of that so you can't develop bits on an old car
exactly
to put on the new car?
So sometimes you can use these events, not necessarily the Le Mans one, but others, to explore a different operating region of that car in ERA, but you can't just go and bolt a new wing on and run away or brake or anything like that. But
sure. But okay, so is it viewed as potentially you can try stuff on there, or you're looking at a concept, or?
Sometimes, let's say if we're thinking you could run a car in a certain suspension configuration because you haven't explored the area for a couple of years, we could ask Jack at just one test perhaps to run whatever was available in ERA, but perhaps we didn't run that commonly, and bolt it on and go, actually, how does this feel now? Because obviously the limitations at the time were P1 into P2Q, and you can't always do a nice comparison.
Sure.
But then the whole idea of it being 2-year-old cars is that it's not directly transferable. In addition, the tyres that we run are not exactly the same as the tyres that we were running at the time, so there's just enough there to blur any conclusions you might think you can draw. So primarily we use it as the driver training.
And how far back does that rule apply to? Like, is it still applicable to the 2012 cars?
No, so the E20, so the 2012 car, runs under the THC regulation, which is the testing of historic vehicles.
Right.
And it's a lot more open, basically. There's a few interesting, there's a few tidbits in there which still apply throughout. For example, any team that has made these cars are not actually allowed just to sell them to somebody without the FIA's okay to actually sell them. So it's all these little bits and pieces that you have to be aware of when we take these cars. I think it's 4 years where it technically enters the historic part of the regulation. So the RS18 now, for example, is historic, if you like, and it won't be long until the A521, which we're running until recently, is also deemed historic as well.
That's how quickly Formula One moves.
It is, basically, yeah. Because even running cars under this TPC is obviously a challenge within itself. We're lucky as Alpine that obviously we've got gearbox in-house, we've got engine in-house, we've got chassis in-house, so we can just ping our relevant corners of the company and we all come together. Whereas obviously if you've got a customer engine, customer gearbox, you have to pay obviously for the rental of such components and organise logistics. So we have quite a big programme because we're in a good place to do so.
Okay, so back to the Le Mans event.
Yes. When
you knew that was happening, what was the approach? How did you adapt the car? Where did you start?
So if we've done laps, perhaps somewhere like Assen or somewhere like that, which is a bit simpler because it's just a standard, if you like, circuit. So those we've approached a bit more, not gung-ho, but we understand the energy and the connotations of the circuit. But obviously Le Mans is quite a bit different, so it did need a little bit more exploratory work. The first thing, as you've already hinted to, is being able to simulate a lap is quite important. Obviously most of the circuits we go to, so any F1 car we run anywhere, we would have a lap export that we can pull out the data of the car and then simulate any model of year car around that given lap. Obviously we've never been around Le Mans before, but luckily our colleagues in LMP at the time had, so they were able to supply us a base data set that represented a lap, and then we plugged that into our simulation software so we could actually start examining and scanning where the optimum setup of the car should be. So we did approach it in a way that, what's the fastest lap we can get out of this car around this circuit.
And just to go into a bit more detail about the simulation work, because that fascinates me, what does it look like? You know, is it taking in, of course it's taking in kind of the track map, is it taking in bumps, camber, is it taking in the surface, and then how does it feed it back to whoever's reviewing it? Is it graphs, is it like a speed trace?
So ultimately what pops out is if a car has actually done a lap.
Okay.
So you actually get a time history, if anything, obviously more info than the car, because the car itself is a function of what you decide to log sensor-wise. But obviously every corner of the simulation model, every displacement of every part of the car, we know exactly what it's doing. So what we have is a couple of components to the simulation. First is what we just call a steady state lap simulation. So that's with no ride inputs, it's just taking a mathematical model of the car, driving it around a given curvature for whatever the lap is that we choose. And then obviously we get a full idea of how it would be driven, first of all. So obviously where the car technically could be flat out. So we consider basically two regions of a track. We have a PLS or a GLS. You're either grip limited, so laterally it's having to be sub-throttle because it just hasn't enough performance to corner any quicker.
Yeah.
Or PLS, which is power limited, which means ultimately at this point the only thing you want is more power.
Sure. So corners and straights are essential, bits that are not straight but flat out at least. Yeah. How do you deal with something that is almost or just about flat out in the right conditions?
That is the difficult one because we've this core steady state sim is basically the core of every pre-event project we do before every race.
Right.
So for Barcelona coming up, we've got the A524 as this base model. We will throw that around a lap. We will then basically scan almost every setup option that there is on the car: ride heights, spring rates, mechanical balance in terms of roll couple distribution, roll stiffness itself, what rear wing, what front wing setting.
So it's trying combinations of all these things.
You get a whole matrix, and from this it should pop out what the optimum setup for this car is.
Yeah.
What that then provides is like a baseline starting setup. So often that combination of things where we'll get sensitivities to, okay, this is the rear wing, that should go on, but you might sometimes have two wings that are fairly close. That's where things like the simulator can come in, because you can take that base setup. Both of our guys will be in the sim before every single race, basically scanning if there's sometimes a question. Let's say you've got a low sensitivity to a heave stiffness, so a spring rate. You might get them to try both, so they have their opinion, and then we might pick that to be one of the things that we try in a P1, for example. Or if it's close on rear wings, you might get the two to try different things in P1 as well. So in terms of Le Mans, that at least gave us a quick and dirty insight into where the optimum was. Obviously with Le Mans it's not a surprise where the rear wing and ride heights, it was just everything was drag related effectively. So what we had to do from there was just dig out everything we could that the optimum sim indicated it should be. So we had the Monza rear wing on, we had the lowest ride heights we thought we could as a start point. I don't know if you recall that era of F1 car, across most of the grid was also the hydraulic suspension, so you could set that up in a way that kept rear ride height low. You could have collapsing rear suspension, all that kind of thing, basically for a slippery car.
And that Monza rear wing, I know it's for Monza, would you have gone down even further for Le Mans?
Yeah,
would you take some out of it?
Even at Monza, when you've got the extremes of the circuits like a Monaco, and a Monza, often the scans will probably point you towards more of what you've got.
Yeah.
But obviously, as a company with cost cap, with the benefits you get of one race versus developing other interstitial wings, it's always a sporting decision actually as to how far you stretch beyond these extreme circuits.
Yeah.
So Le Mans was a very clear, almost take the wing off type scenario, but we weren't going to do that.
And so you run it in the sim, and then basically you're using the parts that you'd already developed, I suppose, like the Monza rear wing and whatever the front wing was.
Yeah, so the sim itself first, as with any simulation, obviously parameterization is key. So there was a few things about the RS18 being run under the TPC regulations that differ slightly. For example, part of your sporting regulations is also adhering to what Pirelli prescribe as operating conditions for the tyres.
Right, yeah.
Under TPC, Pirelli rightly are typically a little bit safer in terms of the temperature you can heat the tyres up to, and also the starting pressures as well, because obviously in a race weekend you've got a fleet of Pirelli engineers making sure the tyres are being used properly, whether you're overusing shoulders, all this kind of stuff, and they will move pressures during the weekend. For TPC events, obviously it's just us and a car.
Yeah.
So typically the pressures we have to run are slightly higher than in a race weekend. So again, it's just a key thing that when we did the simulation, we represented the actual tyre pressures that Pirelli will be asking us to run at.
For the viewers, why are Pirelli making you run higher? Why is the higher tyre pressure deemed as being safer?
So generally, underinflation is where construction damage can come from, because you can almost start running on the walls, if you like, of the tyre, especially when you're very heavily laterally loaded.
Yeah.
Whereas if you put more pressure in, technically you lose contact patch area, so reduced grip overall, but it's generally a safer condition for a tyre to run in.
Because stiffer.
Yeah.
Stiffer, kind of a bit less grip as well, so it doesn't flex as much.
It's just basically less deformation of the carcass.
Okay, so you changed the wings, you ran the simulation. Was there anything else that was different with the car?
Yeah, there was a couple of things. So it all sort of unearthed us obviously exploring this stuff. Even things like the fact that our PU, nearly all PUs, as a function of any kilometre done, it will get degraded performance. Obviously we didn't have fresh RS18 equivalent engines at the time, so we did rough calculations based on the mileage the PU had done to make sure that we represented the actual power that was available. And also, just sort of going round in a circle a bit, the core part of this simulation almost is a chassis component and also a PU component. So we've managed to set the car up mechanically and aerodynamically where we want, but our PU colleagues need to know what a lap is like in terms of how to use the battery around the lap.
Sure.
So as with any race weekend, and including this one, typically you will do a first simulation as if you don't care about battery. You'll just do this flat out lap. This is what we would ideally like. Our PU colleagues would then take it and basically do a similar thing, just scanning different ways to deploy the various levels of K-clip, H-recovery, all these kind of things. And they will send us back, this is the ultimate power deployment around a lap that will get you the fastest lap from a PU point of view. So we did that for the Le Mans lap as well. So
okay.
we had an optimum chassis setup. We knew where we were going to run the tyres. We could also do little tweaks, things like DRS, which typically obviously the FIA set where you're allowed to open it. There's no regulations for the Le Mans lap, so we could just basically map the car to allow DRS on every single straight.
Yeah.
So we had a low wing, DRS open, low ride heights, and just the slipperiest thing you could think of on all the straight lines.
Was it significantly slippier than you might see at a kind of normal circuit like Silverstone or Spa?
It was probably, it would be similar, but it's just the duration of the lap that we were able to do it at.
Right.
Because we didn't just have this single DRS zone. It was out of every single corner. Fernando was basically straight on to DRS.
Straight. And so what was how did the top speed compare to somewhere like Monza? Was it, I guess it wasn't that different.
No, because a lot of these circuits like Monza were actually not far off a terminal velocity these days. So all we were was at terminal velocity for longer, effectively. So it wasn't too sort of exciting in that respect. The only things we did sort of unearth is, obviously for a couple of decades, Enstone has been operating these cars at race circuits. Code and software has developed obviously through the years, and people have put in little catch nets and things like that for whatever the purposes were. And we quickly found out there was a few things that actually needed work on, because we found a few examples where the car would actually reset itself in terms of where it thought a start of a lap was,
right? Because
it had reached 10 kilometre.
And it hadn't been programmed for any more than that.
So for things like knowing where you can open DRS, for our PU colleagues' deployment to work properly, it's all based on how many metres it's gone around the circuit. So there's two things obviously needed there. One is to know when the lap has started, and then for it not to think it needs to reset itself after 10 kilometres.
Yeah, it's almost timing out. Yeah, I thought you were going to say like throttle being flat out for a period of time or something, but it was a kilometres.
Things like that was still a concern, because obviously energy duty cycles, temperatures, all these things still need to be considered. It's just, even in race weekends, for example, on a much shorter one, if the car hasn't seen the control line after X seconds for a given, because obviously it knows the speed and everything else, when it should roughly be coming up, it will put in a forced lap marker, just to try and keep things in a rough lap count that's close to reality. And in terms of the RS18, there was a few corners of the code, if you like, that had 10 kilometres in it, so we had to rewrite a few bits of those.
Sure. And did that stuff come out in the simulation, or incredible? And things like cooling, like being flat out for so long, was the the engine, the gearbox cooling okay with that, or when's the highest stress for the engine in terms of like heat management?
So PU and temperature control isn't my forte, but what I do know generally is speed is typically your friend, because obviously it's just a mass flow that you want. So even on race weekends, if you're going slow, you'll ask a driver to speed up a bit just to increase the flow, because ultimately the engine is still doing work. The temperature of the PU is not changing considerably as a function of the energy it's outputting. It will still be at X temperature.
Yes.
It just needs the airflow to go through it.
Got you.
It wasn't too bad at Le Mans.
No, I suppose if it's flat out, in top gear, getting loads of air through it, it's fine. If you're flat out in second for a long period of time and not going that quickly, then
you can still have a certain RPM, you can still have a certain amount of throttle, but you can be at 100 kph or 250, and it would much prefer the 250.
The glorious air coming through. Yeah. Okay, so I guess the next logical question is, during the simulation, what was the lap time? I mean, I've just come back from Le Mans. I think the quickest lap was a 3-minute 20 something.
So I thought about revealing this, but I won't.
Oh, come on!
But I did. So I was having a dig through. We did actually. I did dig out.
Trace. You're teasing me.
What the actual lap? There's a few caveats here, obviously, because this is, if we took the RS18 model as it raced, with tyres obviously as it raced, so its optimum grip, and then allowed someone to drive the car to the limits that the simulation could do, we would be achieving a lap time that on prediction would have been a lap record for the circuit.
Okay.
But the caveats here is obviously through some of the last, is it the Porsche? Whatever
Porsche curves.
Porsche curves. It was fairly confident it could pretty much nail the car through those corners.
Right, okay.
The reality of us having one lap, we also had logistical debates, if you like, about preparing the car. For example, a picture with, so this was basically our garage.
Right.
So that is all we were offered in terms of room in the paddock, just sat at the end.
Were you in the pit lane? I can't see.
So the pit lane was up here, and there was just a gate out onto the circuit.
Right.
So we had no power, so we weren't able to keep tyres on temperature, for example. And obviously everything to do with this lap is everything being optimal, and then the driver being able to exploit everything from it as well.
Yeah.
So
not just doing one lap.
If we'd have had a day, and we could have actually got everything settled, balance, ride heights, etc. Because Fernando was also quite engaged with the project as well. We did have some to and fro. He offered experience from where you need to watch for minimum ride heights, because obviously it's a real road, so there's a bit of curvature. So we played it a little bit safe on things like ride heights as well. And then obviously the lap itself ended up not being a full push lap. A
complete lap? Because you caught some traffic at the end of it, right?
Yeah, unfortunately having a full push lap was sort of scuppered from the start. We talked about needing to know where the beginning of a lap is for DRS mapping and PE mapping. We learned not long before that we weren't going to be able to have a lap trigger nor pass the control or the start line. So we didn't actually have a very accurate, what we call S-lap, so how many metres into the lap the car was.
Yes, of course, yeah.
So as Fernando rolled out, we basically had to force a rough minus number, knowing he was going to deploy somewhere a bit down the road, just to make the car think it was in roughly the right place. So we didn't have a good start point. Obviously we didn't have tyres on heat. Then obviously there was the parade at the end, which didn't allow for a full push.
No. He caught it quite quickly.
He did.
Was that quicker than he was expecting? I watched the footage earlier.
I was slightly concerned because we had to quickly escape back to where he was going to stop. And seeing some of the aerial footage with quite a lot of plank wear sparks coming out the back, I wondered if we had not quite estimated the ride heights correctly. But he was definitely pushing for the first bit.
Yeah, when he was alone on track, he was pushing hard, right?
Yeah. So I think there's a small lock-up even straight out of the pit lane again. That's just a function of there was about an hour from us basically leaving. They allowed us to have an actual workshop about half a kilometre away. We then kept the tyres on heat as long as possible. We then had to tow the car on the wets that you've seen to the point, and then we brought the blanketed slicks as late as we could to the car, but ultimately you're still just losing temperature.
Getting rid of the heat.
The only caveat is, so the TPC and THC regulations with Pirelli, there is a specific family of tyre, and generally it's made to be a little bit kinder, perhaps at low temperature, which is why the E20, for example, can go out with no blankets and still offer you something. If you plotted if you put on a graph the stiffness or grip of a race tyre versus what we call the Academy or demo tyres, you get very close when you're at the 80-100 degree region. But the journey there is much kinder on the Academy ones. It's much flatter, whereas if we had left with a race tyre at those temperatures, the grip would have probably been a good 20-30% less.
Right, okay, got you, understood. So to go back to your previous point about the lap time.
Yep.
Quicker or slower than 3 minutes, if you can't be specific.
I will double check my numbers first, but I will give you a number. But so this one, for example, was an early simulation before we had actually prioritised how we were going to have the battery management.
Yeah.
Because typically, obviously, most straights in F1, it's fine that you just have a sort of clean reduction just for the last X seconds.
Yeah.
But if that was to happen here, it's a large proportion of straight. So we were looking at actually staggering. So at the end of the straight, you would have had less energy than you would if you were having a typical clip in a F1 race event. But with this sort of lap, you actually end up with an optimum lap time by just staggering it a little bit more.
What, so you use the energy a bit more gently throughout the entire straight rather than...
Yeah, so as opposed to just having this big cut, you could actually have a little one and then just gradually reduce it as you go. Because obviously the typical exponential function of drag and all this kind of stuff, then just a simple cut was probably not going to be the simplest way to do it.
Got you.
I will.
You're trying to distract me.
No, I will. I will get you a number, because even things I'd say like the PU aging, all these kind of things. Yeah. But I think at the time I looked up, is it still a Toyota? I think that still holds
Toyota,
the records.
Yeah.
I think when I looked at it crudely, if we included the amount of clipping that our very PU colleagues were going to say was needed for a single lap, it was going to be 2 or 3 seconds quicker than the lap record.
Okay, yeah, which is a 3:18.
Yeah.
Yeah. Okay. I reckon Fernando would have gone quicker than that.
I mean, what I was hoping obviously was to use his experience of the circuit not long before our event as well.
Yeah.
But ultimately, we didn't have everything in place to be able to do a full push lap.
Sure.
Other limitations. Just to continue with simulation. Obviously, it's a type of driven lap that we've not often done. So, almost like you were hinting to in terms of the PU, in terms of what you might call a duty cycle. So the power or energy that it sees during a lap. Typically, an F1 car is only seeing full suspension loads for an X straight length, so whatever, 10 seconds in some of the places. So we were also just double checking with the designers that actually if we see this load now for 20 seconds, is there any negative or sort of concerns, if you like, of running suspension components, wheels, all this kind of stuff in a different rate of energy, essentially. But in actual fact, when you look at some of the proof testing we do on all the suspension components, it's made to cover all these scenarios. So in the test environment in 18, it had seen much worse things than just a lap of
right. So just to clarify that, of course, going down the straight when you're going at top speed, that's when the most downforce is on the car, therefore the most load going through the suspension.
Yeah.
And because the straights are so long at Le Mans, that kind of period of high downforce, period of high load is significantly extended.
Yeah, and again, it turned out not to be a thing, but it's all these things that need to be considered, because obviously if you think of a way something may fatigue or yield, all these kind of things, it's a time-based thing. You can load something up for X amount of time on a cycle and it'll be fine, but if you hold it to that for a day, you'll probably come back and find it's given up.
Yeah.
Obviously, we're only talking 10 to 20 seconds difference from a normal lap to perhaps what you're holding a straight line speed at in Le Mans, but it's still something that was different from normal. And as we said at the beginning, if you don't approach this as if it is a full event, then you start to miss things and not tick all the boxes.
Yeah.
It can have you over.
And you're still going at F1 speeds, right?
Yeah.
So, just out of interest, what do you remember what the longest period flat out was in the simulation?
I don't from memory, but I can definitely give you a collection of stats.
Yeah, that would be quite interesting just to understand, because it's I actually don't know what the longest circuit would be. Spa maybe from the source all the way up. Yeah, that's quite a long time, right? But I suppose Le Mans even further than that. Yeah. Have you got anything else to go over there, Dominic?
So I think we've been through the base setup. I know you talked about brakes before. The brakes themselves weren't a particular concern. Obviously, the braking event itself is very similar to a normal braking event because it's a similar terminal velocity. The only thing was obviously cooling, because it had a lot of time to cool.
Too much cooling.
We did fit a brake material specs, so it's obviously all the carbon brake material that tend to offer a little bit less a little less friction, but it's just a much more consistent performance through the temperature range. So you can actually run them quite cold, because even if we added loads of blanking to it, it's still going to cool down.
Yeah, because you're only getting it up to a maximum temperature. You're not reducing too much how much airflow goes over.
It's going to drop whatever happens, and you can't stop that. So we just opted for something that was fairly benign to temperature, and then other little things like the brake bias or brake balance. We just made sure that it was sort of fairly rearwards, so we didn't suffer any big wheel lockups or anything like that, because generally if you take some rear locking, as you would call it, it's never a full lockup. It's just sort of micro slipping, effectively. Because
the driver's more sensitive to it, or
I imagine just the PU will always keep it turning, so you can have this feeling of instability if your wheel is not matching the rotational speed of the ground. But obviously if you lock up fully a front tyre and you've flat spotted it, and then you've got a whole world of pain of vibrations, grip, I can't see where I'm going, all that kind of stuff. So
and along a big old straight, it's not very good for the tyre.
And that was definitely not a load case on suspension that you've seen in the past that I wanted to put through on a Le Mans straight.
You didn't want to test it there. Fantastic.
The other thing, obviously, you mentioned max RPM. We double-checked full throttle time. We checked a lot of these things were already seen in dyno conditions, so it wasn't a concern. Whilst we're still thinking about it, trying to be an optimum lap, we obviously got a fuel consumption from the simulation as well, so we made sure we were only just what we needed on board, so it was a low number. With a bit of headroom, obviously, because running out is a bit embarrassing.
A long way back.
Yeah. As well. But yeah, I think that sort of nailed the setup side of it. Again, from the simulation, you just get a whole package of energy numbers from tyre, lateral energies, suspension loads, all of these kind of things, and we just cross-checked that none of these numbers look particularly arrived from where we've operated, at least in a lab condition as well.
And if you were trying to do the ultimate lap and you had budget and team and you didn't have any kind of regs to abide by, maybe, and you could put some wings on it and whatever, would it all be about getting the drag off the car? Is that the
Based
key
on the
thing?
simulations, yes. There's always two sides with those. One, you can obviously get an optimum setup, but if you actually let all of our simulations get you to an optimum setup, the driver probably couldn't drive it, because there's a level of instability that the simulation model is perfectly happy throwing around it at. But if you ask a driver to run the car at its natural lateral capacity within this operating window, it would be nigh on impossible.
Yes.
So it mimics almost what happens in a race weekend, where we will have done all the sims, we know the ride heights, we know what wings to put on, we roughly know what stiffness is as a function of the ride inputs. So just covering that, which you mentioned earlier, the steady state simulation doesn't actually have a ride, a road input to it. We do that separately, so you can distinguish the two individually. The simulator will combine it all together, but this allows you, just in a clean, steady state, what is the perfect thing, and then you can put some ride inputs, what we call basically the road replay profile through it, and that will then start to give you a bit of an indication as to, actually, for this amount of aero, we need to trade some of that for running it a bit higher with a bit more spring movement, running X damping, all this kind of thing.
Yeah. Okay. Fascinating.
And we do that two ways. One is the thing most people have seen, the classic 7-post rig, which is where obviously when almost every weekend when the F1 cars across the whole grid are running, they're running accelerometers on the hubs, typically just on a Friday. And what that gives the team is basically the raw, unsprung road inputs that's just gone through the hubs, basically. So that is now your road profile.
Okay.
You use that data, and you can convert it through tyre model, etc., to give you an actual floor input. You'll then put a car on the 7-post rig, you'll replay what you hope is somewhere close.
Right. Yeah.
You then have all your accelerometers in the chassis, you have all your damper displacements that's happening with this road input, and then you can correlate that to what you actually saw on track. So you might do some tweaks to those road inputs just to get your 7-post experiment to match, but you should be somewhere close to start off with. And then once you've used the physical car to get you somewhere close with this data input, you will then put that data input back into the simulation model, and then you've got a version that's driving around the track and taking the road inputs at the same time.
Okay, so you're going from, sorry, let me get this right because that was quite complicated, going from the kind of simulator through to actually seeing what the actual car's doing through the hubs, to then put that on the 7-poster rig to then feed back into the sim.
Yeah, so it's source data first, typically from a P1.
Yeah.
We then have a real car with a rig that's trying to replicate what the real car saw based on the offloaded data.
Yeah.
You'll use the real car just to tweak a bit those inputs, because ultimately you want to get exactly the same, the car moving in the same way, the same displacements, the same bouncing, all this kind of stuff. The reason you don't get a match straight away is because the tyre in every capacity possible is an unknown.
Yeah.
Everybody's just always trying to perfect their tyre models. So you've taken the best you know, because obviously it's seen a road input, it's gone through a tyre, and then you've seen it on the accelerometer on your upright.
Yes.
So there is an unknown.
You've got
in
one.
the middle.
Okay.
So we have, it's what's called a loaded radius model. So it's a function of camber and pressures, all this kind of thing that gives a displacement for a given vertical load.
Okay.
And we try and use the best of what we know to convert the road input on that 7-post rig. Once we're happy with our tweaked version of those pan inputs, that's when we can just throw it straight back into simulator and the steady state simulation and start adding a suspension, a transient aspect to it as well.
So a significant amount of that just comes from, for want of a better phrase, like the squishiness of the tyre and actually trying to understand that as much as possible.
Yeah, so there's so many sort of corners of the tyre modelling world, because even understanding and getting a good idea for this tyre loaded radius is important for when we start working on what ride heights the car should be. So for example, when we went to the 18-inch tyres just a couple of years ago, it actually turned out that the displacement of the 18s is not too dissimilar from the 13s.
What, the actual displacement?
Yeah, because by eye you would think we've gone from squishy to
stiffer. Yeah.
But in actual fact, for a 13-inch, it was a very stiff sidewall. It's not like you've ever seen a 13-inch F1 car squash it. It still looks like the tyre, just with a little bit of compression. The 18s have a bit more give in them.
Right.
So in actual fact, going into 22, the amount of suspension, travel, the damping, all this kind of thing, it was not actually too different across years.
Because I remember a lot of people saying, "Oh, you need to change the suspension."
And we were lucky. This is a bit of a relevant offshoot, actually. So what the race support team also helped do is help Pirelli by running mule cars. So all teams are allowed to volunteer to support Pirelli with their testing. So during the year, people will always be taking their current cars and running whatever the latest iteration of Pirelli's tyres is. What they also invite teams to do is modify old cars so they can accept, in this case, the 18-inch wheels.
Yeah.
So for a good 2 years or so, we had the RS18 roaming around on 18-inch wheels being tested by, at the time, Fernando, we had Daniel Kiat, Esteban, all these people are doing testing on the RS18 running on 18-inch wheels, and we were not having to divert too much from our normal suspension configuration, which already starts to show you that it's not a big offshoot from where the 13 inches were.
And did you find that information out from the tyres being on the car first, or were you even using those tyres on the rig as well?
Yeah, so for example, when we talked about that tyre loaded radius, which is basically just a mathematical equation with various inputs, Pirelli gave us a first insight as to what that was going to be. So typically we're trying to work that out ourselves because we can spend typically a bit more time on it with rigs and all that kind of thing. But they gave us this first look at where the 18-inch tyre would be, and we were able to throw that again into the same steady state simulation. So just bolt these simulated tyres on and soon have a look at where the ride heights fell and what the ride inputs were like and all that kind of thing.
Yeah, so you had an indication fairly early on with that as well.
And then, as is the case with all the mule car tests, you work in collaboration with Pirelli. So teams obviously volunteer because you get a bit of an insight, but it's actually primarily driver related because all the data, just by regulation, is completely shared and offload to Pirelli straight away. Right. So it's not here's our secret little Pirelli test.
So all the teams get access to that as well?
Yeah. So at the end of every test, for example, Pirelli are sending to us, this is what Ferrari did today, they ran this aero balance, they ran this tyre, they did this lap time, or this kind of thing.
Sure. And the feedback from the drivers, was it significantly different in how the car actually felt?
So one of the biggest differences, so grip level was similar, as we've already spoken about, the construction was fairly similar. The biggest difference is what we would call cornering stiffness, so it's just for a given amount of steer angle, how much lateral performance the tyre would give, and that laterally and longitudinally was much more sensitive. So with the 13-inch, where perhaps you could start to lean on it a little bit more and you'd get a feel from that first input to X steering angle, you had a bit of a higher amount of lock and a bit more feel. The 18-inch was very direct.
Right, okay.
So the car basically felt a little bit more nervous.
A smaller window in which you could feel it.
And the same, if we talk about the tyre longitudinally as well, if we think, if we've got a graph, let's say, of just how much longitudinal performance a tyre is giving for how much you're slipping it up.
Yeah.
The 13-inch could actually take a fair amount of over slipping and keep you travelling in the right direction.
Yeah.
There was quite a drop-off, there was more of a drop-off on the 18s, which meant you just had to balance it in that perfect spot a lot closer than the 13-inch one. So if you went in the same, you could just spin and you would just then start to get some over-rotation of the car.
That's so the window just became smaller, and I guess going into that period, I remember there were quite a few spins actually early on, weren't there? Probably because of that reason.
I think the philosophy of the car helped because obviously they were heavier, they had more load.
Yeah.
But if you were dancing around the previous generation car on the 18s, I think that's when it sort of showed itself a little bit more as being sensitive to these things.
Do you know why with the bigger diameter wheels you couldn't have as much wheel spin and move forward? Like, to me, I can't understand why that might be.
In what respects?
In terms of, you mentioned that you could spin the old ones up a little bit more and still maintain the momentum forward.
Yeah, I imagine we're into the world of construction, so it'll be obviously contact patch load area for a given amount of load and slip and all this kind of thing, and also just how the surface is responding to temperature as well, because the grip ultimately is obviously just a function of load and the temperature it's at. If you're overworking or overslipping a certain area, then you're just going to lose grip and performance. So even with the 13 and the 18 inches, if you do light it up out of a corner or you have a lock-up somewhere, you've created obviously an energy input and a temperature or resultant temperature. Drivers can still feel that a corner or two later.
Right.
So, which is why it's all to do with management and driving carefully.
Yeah, not getting those kind of hot points.
Yeah. You hear it on all the radio transmissions. Obviously, take it easy out of X corner or say even this corner, and it can just be real-time monitoring of the surface temperatures. So we have two ways to watch the tyres. There's your classic TPMS inside each tyre, and then on all the cars there is just basically IR surface temperatures pointing at the tyres. So we can then infer almost what the bulk of the tyre is doing, because we know from the TPMS what's happening inside. We've got surface on the outside.
Got you. Yeah.
And then we have sort of modelled versions between.
So you can see what the core's doing. You can see what the surface is doing, and
typically. Yeah.
Wow, fascinating. So I'm going off on a bit of a tangent here, but this is just interesting to me. So are you constantly relaying that to the driver to get them to manage them better?
Almost 100% with the generation and the way we're racing at the moment. What we do though is we pre-event, we've often tried to just simplify obviously what the requests are. We don't need to start talking in detail on the radio. So the tyre group spend a lot of time pre-event, for example, working out we could save X amount of tyre energy for only X amount of lap time if we did it in this corner and only laterally. The rears will be better if we save a little bit on exit in this corner. We get X amount of energy reduction, but it's only half a tenth of lap time. So the tyre guys will just have all these, typically maps with colours because it's easy to digest. And then on a Thursday with the drivers, they will just sit down and go, this is how we need it driven, and these are the areas. If we say saving 6 is what we're talking about. It's to do with a lateral component on the front left and just take it easy at X point.
Okay, there's a lot of management, and I guess a lot of the driving style is taken from that. If you're looking at the entire stint, they're going to be adapting to try and get the best performance.
You
balance.
would hope, yeah. There is definitely.
And then they just get flat out.
Well, there's also some drivers who will always just like to. It's like classically, if you watch 2000s Fernando onboards, nearly every corner is that push on and then balancing it on throttle. When he rejoined us, for example, we actually rolled out the RS18. We spent 6 weeks or something in the Middle East just making sure he was happy with the dash layouts that the company uses, getting back into speed, all that kind of stuff. And also just our company methods of asking for saving and him wanting to be fed this information so he could then practice reacting to it. And you could still see some elements of that wanting to push on.
There's still a shadow of it.
It's just trying to unlearn, obviously, many years of what has worked before, but doesn't necessarily work for this generation of tyre.
No, and I guess a driver like Fernando can adapt pretty quickly to that.
Yeah, it's not only tyres in that respect. It's if you have a bit of a aerodynamic anomaly, perhaps, if something isn't quite performing, so the balance is then slightly different. All the good ones can basically drive around it. Yeah,
of course. And just to bring it back to the Le Mans event, what was Fernando's feedback about actually driving that car on that track?
Disappointment that he didn't get to do a full push lap, because we were prepared. We had pre-event documentation, we had stats, we had the sims, we knew exactly what we were going to try to do, but obviously it ended up being a bit more of a demonstration.
Surely they didn't want you to kind of go quicker than the Le Mans cars.
No, I suspect that was part of it. I sort of got the hint of that when we weren't allowed to cross the line to start with, that there was no one to start. Even in the depths of social media somewhere, there was no one going to do a lap time recording of it. But actually, just going back to, so if we had a day there, and again it's the same with any race weekend, the simulation should point you basically towards where the optimum is. So obviously if there's no expense spared, we would have probably done an aero package where the return for a given aero level is starting to flatten off. You would obviously put your ride heights where you need to, based on road inputs, based on road clearance, all that kind of stuff. But then the challenge from there, revisiting it, is creating a car around those optimums that is drivable. So it's exactly the same in a race weekend. We will have all these optimums, but historically, obviously, we begin to know exactly what windows a good lap can be driven in. So this is 2 or 3 levers. Obviously, one is roll stiffness, but also the front and rear roll couple distribution, so whether it's obviously stiff on front or stiff on rear or whatever percentage between, that dictates the balance, but also the tyre usage across the axle as well.
Yeah.
As you'll know, obviously you can soften up a rear bar and actually get some good traction because you've optimised the rear axle, but in terms of balance it's not the greatest, and also just perfecting where your aero balance is as well, so basically how much front wing flap you've got. This is what all teams are learning from P1 up to quali, as a function of whether the track temperature is changing, whether the wind is changing, all this kind of stuff. They'll be perfecting sometimes within 0.2 of a degree of front wing flap angle.
Right.
Is where you're trying to nail it down.
To match the circuit evolution and the track temp and the air temp.
So a driver will obviously be saying, I can't take any more front wing flap, or I've not got enough front end.
I don't need any more front grip, thank you.
Yeah. So you're trying to iterate towards this perfect number, but obviously that is for a given front and rear grip level.
Right.
But typically, obviously, the tyres are a different size, so as the track temperature goes up and you lose grip, the axles do not lose grip equal to each other. So historically and empirically, we have an understanding for a given amount of track temp difference, what that grip ratio changes and what front wing or flap adjust we need to counteract for that difference.
Right, okay. So you're trying to find this sweet spot where actually it works well for the longest period of time.
It's why sometimes in a P2 you can have drivers saying, oh, we're all good, this is the setup.
Yeah.
P3, they're going, what the hell is up with the car, blah, blah, blah. And it's just, all these variables kind of change. So even with things like wind, before every session, our aerodynamicist will be feeding through to track side. Basically a lap simulation on things like the load and also where that aero balance will be for the same car with the new wind. So if they've seen it's clocked around whatever degrees and it's increased by 10 kilometres or something, most of the time if you see a driver at what we call the centre island before he gets in the car, there'll be images of what the wind effect will be on the car. Yeah. From there we will say, Jesus, it looks like it's going to be on the nose now in the high speed, let's just take X degrees out of the front wing or something like that, and then we'll re-explore it from there.
And just in terms of the weather, like the wind for example, is it at all predictable? Like, can you see what it's doing in half an hour's time? Or
so I don't know if you've ever seen the Météo France is a company that supply localised weather forecasts at all circuits. So they actually come along and put weather stations to an agreed distance around the circuit, and they offer us radar and radar, temperature and wind basically in real time and forecast by up to an hour typically. Okay. So all the graphics you see on most of the pit wall is supplied by the F1 agreed Météo France Corporation, who do an F1 specific app for that. Long term, you can end up just on windy.com or something, just looking ahead.
I don't know that website, but I'll check it out.
It's very good. It's very good. The benefit with, and I have no affiliation with it, it's a website that allows you to interrogate all the different weather models. So like the free one on your phone will be there, but there'll be ones via more local companies and things like that.
Sure.
But once you're in an event, you've got the most actual recorded data from Météo France.
Right, because it's all about having stations around the circuit to then best predict what's about to happen.
The only downside to that is sometimes there can be a big bubble of something coming in and you don't realise it until it's within our
within the window, and everyone's like, look.
We've had that before. We can have drivers obviously spot for whatever 5, 6, 7k away that there's something incoming, and then you have to dip out to another application to find the bigger picture.
Have a broader view. Incredible. Okay, Dominic, I don't have any questions. I don't know if there's anything else that you wanted to go over.
No, I think that was basically it covered. So to summarise, we did just treat it as if it was a track test, and that's the easiest way to do it. the car at the time had actually just completed like 1,000 kilometres 2 days before.
Right. Okay.
I think we were testing. So the car has actually been driven by, I think, Juan Hujo did a lot of his academy driving in it. Piastri did some training in it. Obviously, Fernando, Esteban. It was Nico Hülkenberg's car originally.
Yeah.
But we had just come from an academy test at that point and just flown it straight to the Le Mans circuit to do that test.
So it had some work to do on it afterwards.
Yeah, we, as with all these things, gearbox servicing, even every half day the car is run, you are taking oil samples and basically you're analysing them for metal content, because that gives you an idea of gearbox wear and things like that. So all of that stuff was done. The wings were changed. The setup, as you've seen, goes obviously on what we call a patch. So with all the beams and the corner scales, we did all of that at the circuit that I can't remember prior to it, because we just knew once we were there we weren't going to have the facility to do that properly.
Sure, it must be quite unusual actually being there and not having the proper kind of garage setup.
Yeah, you need to think a little bit differently, because obviously there's a lot of people who just always want to operate in that given way. You just have to accept that in some cases you need to do it a little bit differently.
A bit differently. You're in the back of the paddock.
Yeah.
Fantastic.
But yeah, that car retired. That had done a lot of miles by the time it had finished. The A521 we inherited at the beginning of 22, which is what we did most of Oscar's program with, and then the RST race support team are now operating the A522. So we moved over to the new big generation of car. And Jack has done a couple of 1,000 kilometres in it so far this year.
Fantastic. Very good.
All good.
Okay, Dominic, thank you very much for your time.
No
really
problem.
Appreciate it.
All good.
Thank you.